I'm Stephanie Alarcon, and I'm going to be talking about electronic waste tonight. So get ready to get super depressed. So start by kind of laying out what we're going to do. Why am I here? Why should we care about e-waste? Why should any of us? What's the life cycle of electronic waste? What's the regulatory environment? And where do we need brain power? And finally, what industries are in a similar position, could be facing similar issues? So first of all, my name's Stephanie. I work at the University of Pennsylvania as a system administrator. They're also sending me to school to get a Master of Environmental Studies if I ever graduate. Also at Penn, I do some work with their eco-rep and, I don't know, green IT groups or whatever. I'm also on the board of Hive 76, which is a hackerspace in Philadelphia. We have a little bit of activity down in the hackerspace village, so come visit us. I'm really into plants. I do some dabbling in like urban farming and gardening stuff, and I really love bikes, so if you want to talk about gear ratios, find me after the talk. So the reason that I'm talking about electronic waste tonight is I found that an interest in computers and tree hugging, guilty, kind of led me to thinking about electronic waste. As a sysadmin, I have to throw away servers fairly regularly, so this was something that was really bothering me. And in general, when I'm thinking about environmental stuff, I tend to gravitate toward regulatory policy and environmental justice in particular. So, but full disclosure, these are some of the things that I cannot talk about intelligently or reasonably. I'm just not a chemist, so I can't talk to you about like the molecular structure of different toxins. I'm not a materials engineer, so I can't talk a whole lot about good substitute materials. I'm not any kind of an engineer, so I'm not very good at imagining better mechanical processes or chemical processes. And I'm not an economist, So figuring out new models of doing business is kind of beyond my skill set. But I'll do my best. I've done a lot of reading, so hopefully we'll learn something. So what is e-waste and why should we care about it? We're going to talk a little bit about how much is there, how much more we're gaining, what it's made of, why it's difficult to pull apart, and some of the difficulties. So electronic waste, you might guess, are more obviously things like CRTs, old computers, old cell phones, VCRs, TVs, but some unexpected stuff. Children's talking toys, old like Hallmark cards, weird solenoids from your pieces from your car computer. There are unexpected sources of e-waste, and they're growing. We do make a lot of waste. So in here, it's a little hard for me to see with the lights, but how many people in here manage hardware, like routers, switches, servers, tape libraries? Yeah, a few people. I do too, and can anybody shout out, like, about how long do you keep your equipment around? 3 years, 5 years, 10 years? 4 years. 4 years? Anybody else? That's reason, here about 3 to 5. And so that's going to create a lot of waste at an organizational level. I don't know about you, but my basement is an IT graveyard, and I've already gotten rid of a lot of stuff. So each of us are creating a lot of electronic waste as we go along. But measuring exact quantities is pretty difficult. It's trash, so we don't value it enough to track it and measure it, and it goes through all sorts of interesting channels, and it can be really hard to measure. So one of the better ways to estimate it is to take sales data and multiply that by the estimated lifespan, and you can kind of get an idea of how much we're creating. There's a weird complication, a technical complication when you start talking about municipal versus non-municipal waste. So in the U.S., electronic waste only makes up 2% of municipal waste. That's the stuff that goes into our city dumps. But there's municipal waste only takes up a small portion of our waste stream. So electronic waste is in more than our landfills, but the stuff that we as individuals, that we as homeowners and whatever, throw away into our landfills and into our municipal system is what EPA is mostly concerned with, because that's what they manage. Okay, so I was real vague and was like, oh, we can't really measure it, but seriously, how much do we actually make? What is that? Something Electronics Association thinks that per household in the US, we have about 24 devices. We think we get rid of about 5 to 7 million tons of junk every year. In the EU, we think that we we think that people are gaining about 10.3 million tons of new devices every year. At one point, the US government found out that they were throwing away something like 10,000 computers a week, and that was excluding the military and post offices. So there's a lot of this stuff. In the US, about 82% of it gets landfilled, and about 18% of it gets recycled, and I'm putting that in quotes, because as we'll find out later, a lot of stuff that gets sent to recyclers actually ends up getting exported, which in most cases in the US is perfectly legal. So Moore's law also applies to waste. CPU speeds go up, but also we're just gaining more waste on a pretty nasty curve. E-waste is the fastest growing component of both US municipal waste and EU manufacturing waste. Between 1998 and 2007, the amount of waste that we collected doubled. And the EU has recognized this and decided to move away from a weight per person collection goal more to a portion of devices that have made it to the market goal to try and track these upward trends. So another reason we should care about it is there's a lot of valuable stuff in here. If you care about conflict diamonds, you should be thinking about conflict coltan, for example. It's a rare substance, and it's at the heart of a lot of conflicts in the Congo. If you care about peak oil, you should be thinking about peak tantalum, the stuff that's in capacitors. It's pretty rare too. If you are concerned with mountaintop removal for coal, you're gonna love gold mining, and we use a lot of gold in electronics. So, for example, in gold mining, for an 18-carat ring, you have to go through 20 tons of mine waste to get that little bit of gold, which is kind of horrific, except that if you take a ton of circuit boards, that's actually 17 times richer in gold than ore. And with those statistics, still only 30% of the world's gold comes from scrap. Here's a picture of a gold mine. You can just see how it's made an incredible scar on the landscape in Western Australia. You could fit a city in there. There's other valuable stuff. There's all sorts of recyclable metals, copper, gold, platinum, nickel, all sorts of nice stuff in there. And if we can pull it out, if we can resell it and reuse it. Computers have, and e-waste has lots of reusable stuff. Glass is very recyclable. Same with ferrous metal, aluminum, all these other metals. Plastics are sort of a different story, but they can be recycled. So we're literally sitting on an electronic waste gold mine, which is awesome, right? So then why is tracking this stuff so difficult? Why is it so hard to measure? Why is getting the good stuff out of it so difficult? Why are we sending so much of it to other places where we don't necessarily want it to end up? And the answer is because it's really difficult to get to. So think of the last 10 PCs you took apart. Unless they were all the same brand, they probably had different ways of physically getting into them. So there's not a standardized way of either separating electronic waste to get to the guts of it, nor is there a standard way of marking how to, putting standardized markings on how to open this stuff. So if there was like a standard set of logos to clue in disassemblers to which screw comes out next so that you don't break the thing, that might help a lot. So you've got your thing and you've taken the case apart. It's taking you 20 minutes and you're frustrated, and then you pull the circuit board out. And now, so it's got like little things on it, right? And so now you have to desolder this. Well, how are you going to do that? You just stick it in a toaster oven? How are you going to desolder that? So once you get past that, then maybe you want to get to the gold traces on your circuit board. How are you going to do that? Well, one way that you can do it is dissolve it in aqua regia, which for the chemists, or rather the alchemists in the room, you might recognize that as a nice little combination of nitric and hydrochloric acid. And then after you get that out, then you precipitate the gold out with something like ferrous sulfide or some other chemical. So that might be too much trouble for you. You are not going to do this in your kitchen. Your housemates are going to kill you. So why don't you just start with the copper in the cables? Well, all right, are you really going to sit there with a box of Cat5 and strip every cable to get the copper out of it? That's pretty time consuming too. So it takes a lot of time and energy to get this out. But it turns out that labor in other parts of the world is cheap, good facilities are expensive, scrap prices are weird, and we end up with this weird situation in which separation is largely a manual process. Another barrier to get into the good stuff is that there's a lot of nasty stuff in there. Computers can be 6.3% lead. I've heard estimates that CRT has like 4 to 8 pounds of lead. And if anybody who has a 100-year-old house like I do might know that lead is a pretty bad neurotoxin. You just don't want it around particularly children, but it can be harmful to adults too. Flame retardants are just ridiculous. Mercury is also a neurotoxin. So you have to get past all that stuff to get to the good stuff. So we find ourselves in a process system that's just kind of stupid and expensive and stupid expensive. Maybe that's not true. Maybe this is good for the economy. I don't know. But one of the things that I think is just kind of silly is the planned obsolescence model. I consider a server a durable good. So is 3 years really durable? To my mind, it's not. We don't have a whole lot of consciousness about producers taking back their trash when they're done with it, taking on the responsibility for the disposal. We don't have a whole lot of thinking about designing for the environment, designing so that things can be disassembled, so that you can pull the valuable stuff out of the carcinogenic stuff without finding yourself with cancer 20 years later. So we've all seen like swappable parts, like hot swappable power supplies and the whole thing. So I'm interested in the reasons beyond the economic reasons why every part of a server can't be as swappable as a PCI card. I understand that there are design upgrades and that sort of thing, but our department just bought a Qualstar tape library that's going to last us 25 years, and we can swap in drives and whatever. So is a backplane on a blade center really so special that I need to swap it out every 3 to 5 years? Another reason that we ought to be concerned about the way that waste gets exported to other nations is once your hard drive is out of your control, you don't know what's happening to it. A lot of recyclers claim that they do data destruction, but either their methods aren't rigorous enough or they're just not doing it. And you end up with situations where, in this photo, it's a little hard to see, but there's an asset tag from the school district of Philadelphia. That came up in a Frontline special. In a movie called Digital Dump that the Basel Action Network put out, we saw a Swiss forensics expert take apart a hard drive from some organization in DC and pull off like child welfare data, information about kids who had been removed from homes and put into other ones, really confidential stuff, government contracts, defense contracts. This stuff is regularly used for scams and that sort of thing. As we've talked about a little bit, we know that disassembly is tough and dangerous, and so it tends to flow where labor is cheap and where regulations are not so good. These places with those situations tend to be the places where there's a lot of poverty and where worker protection maybe isn't the top priority. Those are the conditions under which you get massive environmental injustice. If you look on YouTube for Good Magazine, they have a really cute little 1 minute, 30-second video that outlines the whole thing in a very concise way. But we find ourselves in this economic situation where it's expensive to process it here, and it's cheap to think that it's being recycled and send it somewhere else. And it gives us some pretty bad results. In the places where people are doing informal disassembly, there's a river in Guayu, China, which is considered sort of the capital of e-waste disassembly. There are waterways that have had so much aqua regia dumped into them that their pH reading is nearly 0, and this is a river. In 1996 was the first year that Guayu started accepting e-waste imports. Prior to that, it was farmland, it was rice land and rice-growing land, and within 1 year, their water supply was devastated. You couldn't drink the water anymore. Their soil, their previously farmed soil, is considered hazardous waste by any number of national standards. It's got all sorts of crazy stuff in it: chromium, cadmium, mercury. You can't eat the stuff that comes out of the soil anymore. It also turns out that so Another thing that happens when you send donations and kind of dump them in a place is that that place is now inundated with this product that otherwise they may or may not have developed in their own economic situation. The same thing happens with used clothing. So when you take your clothes to the thrift store, a couple of them end up getting sold in your neighborhood, and a lot of it ends up getting exported largely to African cities, where the problem there is becoming that the local textile industries have become very depressed. The same thing is happening particularly in Africa in the tech industries. There are some really, really smart people, and there's just not the opportunity for them to compete with the incoming imports and make new stuff. There's a healthy reuse market, but there's just not the same opportunity for innovation that we've had. When workers are going through this, they take on all sorts of risks. We've gone through some of the chemicals that people face when they're disassembling. Some of the bad ones are fumes when you're desoldering. People are instead of using hoods, which are just lab hoods, which are not available in backyard processing facilities, and I really do mean just people's backyards. People often use just kind of house fans to try and blow the fumes away from their faces. I've never seen a picture of anyone wearing a respirator. A couple times I've seen someone kind of hold a handkerchief up to their hand while they're working on this stuff. But the workers who take this on for us are putting themselves at incredible risk. Kids are smashing through the lead curtains in CRTs to get to the copper yoke, and there are some people who have gotten so good at identifying plastics that they understand which kind of plastic they're dealing with by the smell if they burn a little bit of it, which is an incredible skill. So here are some pictures. So this is the kind of situation that our old computers are finding themselves in. Here's a woman taking off the yoke of an old CRT to get to the copper. This is a waterway. You can imagine that waterway is probably extremely acidic. I want to pop over to this before I go back to that quote and just kind of mention that, well, discuss that what we're looking at right here, this is environmental and economic injustice. This is the definition of it. This is a group of people in one situation finding that they are choosing not to, or they cannot afford to take care of their own problem, and they're sending it to a place that through limited options will do it for us. And the quote that I really like is from a gentleman named Sheena Badaru. He's the founder and editor of a magazine in Lagos called Technology Times, and the quote goes, "What Africa needs is to be able to evolve its own information technology industry, to support its own local system builders, to be able to evolve its own local computers, to be able to write codes in its own local languages, to meet its own local need. Africa does not need the used equipment coming in from the north to come in here and continue to pose long-term threats to our environment." So this is like the tough part of where our waste ends up, and this is why we're interested in looking more carefully at life cycle analysis and regulations and what we need to be doing next. But before I move on, what I want to do is kind of do a choose your own adventure. At this point, I can go in and start talking a little bit more about life cycle analysis and the amount of material required to create like a computer chip, for example, just so we have an idea of what masses of materials we're looking at. Or I can kind of breeze through some of that, get to the part where we really need good ideas, and extend the question and answer period. So I guess the choices are richer discussion or richer body of information. It's really, can we put the lights up just real quick? Can I get a tech? All right, thank you, awesome. So, poll, discussion versus more talk. Discussion? Okay, more talk? Okay, there will be question and answer at the end. It'll just be a little shorter. Okay, thank you so much, appreciate that. Okay, so let's talk about life cycle analysis. So when we talk about life cycle, we can talk about it in it, and also text, you can do whatever you want with the lights. I'm fine either way. So when we talk about life cycle analysis, the best thing that we can talk about is start with the inception of a product, understand what materials and energy and resource use went into it, understand what resource use goes into the useful life of the product, how it's then going to be disposed of, and how that wraps around to get recycled and made into a new product. So that's the best way to talk about life cycle analysis. It was in vogue a couple of years ago to be really progressive and talk about cradle to grave, which was, instead of just looking at the use phase, which was the popular thing to do prior to that, to look at that inception and go all the way to disposal. So that's better than nothing, but more or less what we do when we're talking about electronic waste is we really are talking about the inception of the product, and then we kind of stop thinking about it once the check has been signed, once the receipt has been generated. I'm sure there's lots of curious engineer types in here, so just out of curiosity, I decided to put this in here. So this is what goes into a silicon chip. So we've got some silicon, we've got some things that I can't pronounce, we've got some chemical input, water, pure gases. Then we end up with this big wafer, which then gets chopped down into individual chips and stamped with whatever it's going to be. So that's kind of the stuff that goes into a chip. I'm not going to read you these chemicals, but there's a lot of consonants. And so there are about 500 to 1,000 chemicals that go into the manufacture of a computer chip. And it turns out that this is stuff that you don't want in your air, you don't want it in your water, and you definitely don't want it in your tissue. But it's getting there. Chip manufacture requires a lot of water, so there's a lot of solvents, there's a lot of aqueous and liquid stuff. One of the big problems that Silicon Valley and the sort of Pacific Northwest is dealing with is leaking underground storage tanks. So there's really nasty stuff leaking into the soil and has been since the 70s. We see flame retardants showing up in biological tissue everywhere in humans and in animals. You might have heard about Scotch Guard showing up in breast milk. There's some nasty stuff that comes out of these processes when the waste isn't handled properly. Okay, so let's talk about a 32 megabyte RAM chip. Do they even make those anymore? I'm sure this study was from like 2001 or something like that. But I think we can imagine that that the scale of materials use is probably similar. Okay, so the energy that goes into the care and feeding of a 32 megabyte DRAM chip is if you think of 100%, the amount of energy that goes toward the use of that is only 25%. The rest goes into the manufacture of it, and that's the case for a lot of products. That's a concept called embodied energy. It took so many kilowatt hours to make this notebook, for example. It takes about 6,000 megajoules to make a computer. Some semiconductor sites find that they're using 4 million gallons of water a day, and you might note that there are chip manufacturers in very dry states like New Mexico and Arizona, and so that's just incredible water use. Okay, so, and it also turns out that a lot of this stuff is just junked before it even gets off the factory floor. I talked about the confusing distinction between municipal and non-municipal waste earlier, and one of the things that confuses that issue is the fact that 70% of hazardous waste, which is not municipal waste, is electronics. So that's stuff that's coming from the factory floor, I think, and actually I was just talking to my colleague John earlier about that. So we can also estimate that for every pound of computer, I think this is like 2.14 pounds or something like that, you can estimate about 2 pounds of waste, and about a third of that will be hazardous. So then we get past the manufacturing stage and we use it for a while, we're reading our email, we're going on to the Twitter, and we're doing the Facebook and all that. And then we're done. So then what do? Well, we have a couple of options. We can toss it in the trash, and there's an 82% chance that it'll end up in a landfill. We can dump it in a closet, which is a totally reasonable thing to do. In fact, the EPA has measured that we probably, as Americans, we probably have over 200 million devices stashed in our closets as of 2007. Another option is you can donate it to somebody who needs it. Totally great thing to do. It extends the lifetime of the electronics. It saves more electronics from being manufactured. It gives the thing a second lease on life. Hopefully helps somebody else. The problem is the chain of custody has been broken, and now that person has maybe, a year, 3 years, 5 years of life left in this piece of electronics, and then they're responsible for the disposal. Or you can recycle it, which, as we learned earlier, can be really sticky, and we'll talk a little bit about why that is, but a lot of recyclers are actually mostly exporters. So how do you find a reasonable recycler? How do you find a reputable recycler? In the US, it's a little tough. One of the things that you can do is go to a reputable voluntary auditing organization. The one that I like is an organization called eStewards. You can go to eStewards.org and find an audited recycler. I like them because Silicon Valley Toxics Coalition likes them, and I really like them. So I think that they seem to be the most reputable voluntary auditing system in the US. But we still think that we're exporting about at least 10.2 million computers just as of 2002, and I'm sure that number has gone up. Okay, but is this stuff really obsolete? We can reuse the glass, we can reuse the glass. There is domestic recycling facilities for that. Plastic is really tough. Just recently, there's been a little bit of an uptick in the market for recycled plastics because computer manufacturers have caught on to this green thing, and now they want to advertise that they have like recycled content in their computers. So they're calling up recyclers and being like, "Hey, do you have some recycled plastic for us?" And they're like, "No, we didn't think you wanted it. We sent it to China." And so even when you're greenwashing, you have to wait for the market to catch up with you. And it turns out that the market is that way because one number that we have is that it's 10 times more profitable to export a monitor than it is to try and process it here. That is leaving us with a really hilarious trade imbalance where we're exporting some technology to the rest of the world, but we're actually exporting more technology trash than actual new technology. Here's another approach to the life cycle. So instead of I buy my laptop and I use it for the Twitter and the Facebook for a little while, and then I put it in my basement or I give it to my niece so that she can learn Ubuntu. It's so cute. So if instead of doing that, why don't I sign a contract with Toshiba that says in 3 years they're going to give me a new laptop and I give them $50 or so, I don't know, whatever. And instead of owning the object, I'm owning the use of the object. Interesting. UN Environment Program researchers, particularly in Germany, are really smitten with this idea, and they really want to make it work. It seems to be working for the solar panel industry. The incoming cost of solar panels is just ridiculously high, but programs where companies are leasing the solar panels to homeowners and the homeowner pays a lower electricity bill in return for the solar panel company getting the extra money that comes back from the electric company from the extra power generation. That seems to actually be working. We'll have to see if it withstands the economic tides, but seems to be a decent model. One of the problems with leasing, in addition to lots of consumer perception ideas, is that it kind of goes against the maker aesthetic. If I can't rip apart my laptop and put things in it that blink or scan your brain stem or whatever, then I can't consider it mine. If I have to give it back to Toshiba, then it has to be in some format that they'll accept back. So there are problems with the leasing model, but it's worth considering. The leasing model also is referred to in some situations as an example of dematerialization, where you've stopped, as I said, you stopped imagining your computing as a thing that you own, and rather it's a service that you rent. Super old school mainframes used to do that. Like IBM used to charge by the CPU cycle. There's got to be somebody in here who knew that, but in any case, apparently that was the case. So we could do that, but there are other ways to think about this idea of dematerialization. So my cell phones are tiny and computers are getting smaller, and doesn't this mean that we're creating less waste? Like when I put this in a landfill, it's smaller, right? So this must be better. This must be greener. I'm getting more cycles per kilowatt hour. That must be a good thing. But it turns out that as we said before, for every pound of this, there's 2 pounds of waste. For every one of these, you can imagine that 630 of these represent the mass that was required to make the final product. A microchip that's 2 grams might require 1,600 grams of fuel and chemicals to create it. So we haven't really dematerialized, which is a point that a researcher named Eric William makes, and I just love this quote. I was like it was in the middle of the financial crisis, and I was just like had my fangs out, and I love this quote. He says, "Our point was and is simply that the amount of materials used to manufacture a computer chip these days is hundreds, if not thousands of times greater than the quantity actually embodied in the chip. This makes the weight of the chip a misleading indicator of the amount of materials used, and it means that people like Alan Greenspan and Francis Cairncross, who have cited microelectronics as an example of radical dematerialization, have misunderstood the situation." Another way to think about this is the information economy really in the ether? No, it's not, and I know that because I manage the SAN. It's a big chunk of hardware. Okay, so let's turn all this around. What if manufacturers took out their own trash? Why should I pay for HP to take care of its own waste? And I totally have the wrong version of this presentation here, and I know that because I totally shouted out my friend John McNabb here, who gave a talk earlier on producer take-back. The idea here is that if the manufacturer is the one responsible for the waste, that flips all these economic models totally around. They start thinking about the importance of building things so that they can be taken apart. They start thinking about the toxicity. They start thinking about standardization and how long they want to make their materials last rather than how short they can possibly make them last. So I refer you to a recording of his talk for a richer explanation of the idea of producer take-back. Okay, so this producer take-back stuff makes so much sense. Why didn't anybody think of this? The problem is toxicity is cheap for some definition of cheap. And this is where we get back to environmental justice again. It's expensive for us in the US because of our regulatory environment largely, and because of the way our economy works, to process this stuff reasonably and well and safely. So we pass the costs onto other people and other places, and we saw pictures of how that works. So basically, this is the idea behind externalizing costs. If you've heard people say that and haven't quite kind of hooked onto that concept, that's what that means. It means that we've decided that we're not going to pay for that, and we're going to put the cost onto somebody else in the form of toxicity, carcinogens, and other sorts of bad situations. So there you go. I did name drop Mr. John. There you go. So extended producer responsibility is a good way to approach this. It turns out that some manufacturers are really looking forward to this. They would like to have producer take back, because if there were that could bring design standards, and if there were design standards, then they could take anybody's computer back and make a new computer out of it. And it turns out that even the industry wants regulation. I've heard this several times throughout my coursework, where someone from some industry will come in and say, we need to be regulated, we want to be regulated. And there are a couple situations under which that happens. One is when there's ambiguity in the law or ambiguity in the intentions in Washington. So if manufacturers or whatever corporations are trying to guess at what the government is gonna regulate next, they have a really hard time, and they end up spending money in inappropriate ways. They end up wasting it. So they'd really just rather know up front, what are you going to regulate so that we can just build for it? The other reason that industry likes the other situation under which industry likes regulation is when there's an uneven playing field, and that's certainly the case in the field of electronic waste. So if everybody had to do things the right way, then you wouldn't be losing competitive advantage over the other company down the street who's not doing things the right way. There's also a statistic that looked at four state legislation programs and found out that the deadweight cost of having 4 individual programs rather than one big umbrella federal program was like $25 million a year. So there's just operation costs in not having an overarching system. So what regulations and enforcement do we have? Yeah, let me skip forward. Oh, I did do it right. Okay, so we'll start with the Basel Convention. The Basel Convention is it's a treaty that was agreed to in 1992. There are 172 parties to it. The convention came together in 1989 in response to a big toxic spill in Nigeria that happened in 1988. And you can consider it the gold standard of international hazardous waste treaties. It governs the generation, the management, and the movement of waste across national borders. And you'll never guess who's not a signatory to this treaty. Actually, that's a good question. John, do you know?
I think China is.
I believe that, because, yes, I think you're right.
They're trying to enforce it in China.
Right, but the US is not a signatory. Okay, so over in the EU sort of has the gold standard of regulatory environment for around electronic waste. And what people are, I'm still doing some research into the longer term effects of these regulations, but they look like they're starting to slowly have the effect that was intended. They have two big regulations that govern this stuff, and one is called WEEE, which is Waste Electrical and Electronic Equipment, and that portion of the regulatory environment handles manufacturer responsibility. So they already have producer responsibility. The other big one is ROS. I've heard people call it RoHS, ROS, all sorts of things. I call it ROS because why not? It's the restriction of hazardous substances, and what it says is that starting in 2002, you've got to start looking at your toxic content. You've got to start pulling some of it out. ROS is the reason that we have non-lead solder in any of our electronics. And it turns out that there's a really interesting little flip of globalization that happened when ROS came in effect. You can read about this in a book called HighTech Trash, where someone from Dell is talking about how when ROS came into effect, they found out that, they decided that it wasn't going to be worthwhile to split their production lines into the European market and the rest of the world. So they just upgraded everything. So now the entire world is benefiting ostensibly from the regulations that are in place in Europe. I just think this is the most adorable thing. It's a small WEEE container, and it's suitable for the collection of small WEEE. Okay, so what's happening in the US? So we have this law, and it's called the CRT Rule, and it's really insufficient. It kind of sucks. Even the Government Accountability Office did a study on this on the CRT Rule in 2008. The CRT Rule attempts to sort of do some of the things that the Basel Convention wants to do only for CRTs, because they're a really big and important part of the waste stream. And so what they're trying to do is say, okay, so if I'm a nation that has a sort of B grade level ability to handle my e-waste, then I can't send it to a level D country. I have to send it to a B or above. And so the CRT rule says this essentially, but there's kind of no way to enforce it, and it's really insufficient because there's a lot of electronics that are left out of this. So when the Government Accountability Office looked over this rule in 2008, they said a couple of things. They said, come on, EPA, seriously, you need to treat e-waste as hazardous waste. This is really silly. There are some really interesting quirks of US environmental law that make it such that if I throw away a computer, it's not hazardous waste, but if my employer throws it away, the same computer, it is hazardous waste. So GIO is saying, just treat it as hazardous waste because it's hazardous. They're also saying, ratify the damn Basel Convention already, come on. They're also saying, for enforcement to prevent some of these mass exports, work with Customs and Border Protection, because that's the only way that you're going to be able to track any of this stuff. But states are picking up where the federal government has not. As of just last month, this is a stat from June, 23 states have e-waste laws. That means that 61% of our population is covered by some sort of producer take-back or some sort of law that covers e-waste. So we're getting there. So when I led a sort of roundtable discussion on this topic at Hive 76 a couple months ago, and one of the things that people were really interested in talking about was mandatory systems versus voluntary efforts. People were really excited about voluntary efforts. The reasoning being, when the market drives an effort, there's motivation, there's impetus behind it. That you just don't get the same kind of enthusiasm, let's say, when you're being forced by some mandatory rule to act in a certain way. And that's a totally reasonable argument, and in some places it works. But what I found and read about in a bunch of places, my hunch has been, and my reading has confirmed, that voluntary efforts just don't get the job done. They're too susceptible to changes in the market. They just don't do it. But there are lots of voluntary efforts out there. E-Stewards, as I mentioned, is my favorite one. EPA has a couple that are, decent efforts, and there are lots of voluntary programs that you can look into. So what can we do as tech workers? We can look at some systemic solutions, and we can look at what we can do. So how do we fix this stuff? And the fixes are actually very simple. Like, when you think about it, when you go through it logically, the answers are very simple. All we have to do is get rid of planned obsolescence, because that's a really big problem. Next, let's make cradle-to-cradle processing profitable by changing the way that we interact with our commodities markets. Let's write really good regulations, and then let's enforce them. Let's go to the places where people are doing informal disassembly and work with them and figure out how we can do better harm reduction, waste processing with people who are actually doing it in the field. And last, let's just pop up some really good recycling facilities that take this stuff apart in an automated and safe way, have really good scrubbers on their incinerators, and yeah, all this stuff is really simple. Except that, let's dismantle planned obsolescence. Sure. It reminds me of that Steve Martin skit. Remember that one where he's like, how do you make $1 million and not pay any taxes? First, get $1 million. Well, yeah, these solutions are simple, but they're not easy at all. But there are lots of organizations that are doing whatever they can to try and address it. Silicon Valley Toxics Coalition is one of my favorites. The Basel Action Network is very powerful in this arena. The Electronics Take Back Coalition is another really good one. You can look down this list. These are some organizations that I really admire. But they're up against some tough stuff. They've got all these economic forces that are just not going to change without all sorts of economic inputs that I don't understand. I was talking to someone from Region 3 at the EPA, and he seemed to think that there were some legal underpinnings of the Basel Convention that made them incompatible with our Superfund and hazardous waste laws. Now, I don't know if that's actually the case, and I didn't get clarification, but if that's the case, that's complicated. Non-lead solder, for example, so replacing substances is not easy. Non-lead solder requires a higher melting point, which requires more energy input when you're making your equipment, which requires your circuit boards to have a higher temperature tolerance, which requires et cetera, et cetera. So replacing toxic substances is not something you can just kind of snap your fingers and do. And enforcement is really tough. Who has time to chase a shipping container around the world except a couple groups of journalists? So there have been some kind of neat green computers. I'll leave it to you to look this up. But what can we do? We are important, and we can make a pretty big impact, because we as technology workers, those of us who are technology workers, we are the market. We form the market. So if we're driving the market, we can ask them and force them to do what we want to do. So I think a 3-year contract is silly, and I've been asking my vendors to give me 5-year contracts. I'm not the only person who thinks it's silly. The Gartner Group is also suggesting 5-year contracts for data warehousing setups, so I'm not the only one saying this. There's a computer consulting company who has been hearing from their customers that SANs are taking like 18 months to deploy and 18 months to decommission, which means once your 3-year contract is up, like, you've just kind of like hit your groove. We can demand that when they ship us a pallet of stuff, they take back all their crap. We can demand that when we're done with their equipment, that they take their old equipment back and give us new stuff. Sun actually had a very good program that did that for a long time, and I don't know if they're doing it anymore. Not they're owned by Oracle, so if they kill MySQL, I'm going to be really mad. So say you work at a university and you have another university down the street. Well, why don't you call up your sysadmins over there and be like, hey, we're making a big order from Dell. Why don't we call up together and tell them to take all their damn boxes back? So the more colleagues that you have making these demands of your vendors with you, the higher a chance you have of getting this stuff through. And use an audited recycler. It's about the best that we can do in the US. When you're trying to make a change in your organization, talk to your facilities people, because those are the people who are concerned with load-bearing capacity of the floor. They're concerned with heating and cooling. So if your organization is being influenced by the needs of the facilities group, make friends with your facilities people. Find out what they need. Communicate that back to your department. If you're in Pennsylvania, you're about to face electricity deregulation, which means that all of a sudden power and cooling is going to be more expensive than it was. So start bringing that up in meetings and be like, hey, we should really be more efficient and throw some things away, or replace them with more efficient stuff. And if you're looking for more impetus, just do like a Google site search of your company's website. Just look for green or sustainable or sustainability, and bring that up in meetings. If there's a mandate from your organization, it means that you can move. Even if it's just greenwashing, it means that it's been written down and you can act on it. I'm going to skip over this one. Just there are ways to make the argument to pay a little bit more at the beginning. TCO costs by a lot of calculations far outweigh, or use costs outweigh purchase costs. So all these things are really hard to do if your organization is just not receptive to it. But if your leadership is growing green, do it. And if you're the boss, why not? You're the boss. So at Penn, we've got a big mandate from the president of the university, and none of us who are taking action in this field really care if she cares. What we know is that there's a mandate. It's on the website. There's a plan, and we're going to take action based on that. So here's where you come in and talk about this with your engineer friends. We need brains on a couple of issues. We need materials engineers to start thinking about safer and non-toxic materials. We need designers to be thinking about cradle-to-cradle processing. We need marketers and people with a really good wooden nickel spiel to convince manufacturers and customers to think a little harder about electronic life cycle. We need harm reduction processing out in the field. We need people who are good at appropriate technology to go into the field and tell us, not tell us, but work with the people who are doing this kind of work and try and make it less harmful. We need better economic models. Obviously, what's driving a lot of this is the money. The money is not flowing in the right direction. It's not going in the right places. We need to fix it, and we need economists who know what they're doing to do that. We need policy brains on better regulation and better enforcement. This is really interesting to me. So we have a really long legacy of electronic waste from the computer industry, and there are industries that can learn from this. The one that obviously that pops to mind most readily is the solar panel industry. They're using a lot of the same substances and design techniques as we're seeing in circuit boards. So with the uptick in popularity of solar panels, we're going to see them dealing with a lot of these same problems in 10 or 20 years, and they communicate that they're an industry that has a conscience about environmental issues. So they may be receptive to hearing about the lessons that we've learned from the electronics industry and implement some of these things on the front end. Nanotech, I've gotten myself into a tizzy. For the past 3 days, all I can talk to my housemates about is, did you know this thing about nanotech? So in 2007, Silicon Valley Toxics Coalition did a study where they took a report from IBM from like 30 years ago and looked at industry data and industry reports from the nanotech industry, and just kind of went through point by point and showed how similar a position those two industries were and are now. We're at the argument that they were making is that the nanotech industry is where the computer industry was 30 years ago, and if we can extrapolate and if we can use the precautionary principle, we can see that we very well may be facing a lot of issues of unintended consequences and bad design, bad planning, if we don't think about nanotech pretty hard now. The last thing is biofuels. So if anybody's ever made any homebrew biodiesel, you know that you end up with like a bunch of fuel and a bunch of like goo, like goopy, like glycol stuff. That happens with a lot of biofuels. And fortunately, that waste is a little easier to deal with. It uses pretty simple hydrocarbon chains, and they're easier to convert that waste into a waste that you can use. For example, you can make like soaps and stuff out of your biodiesel waste, and there are other biodiesel wastes that are being converted into different types of fuels. Alcohols are being derived, and different hydrocarbon-based stuff is being derived. So it's a little bit less of a nightmare scenario to me, but it's a field where I think we could use a little bit of thought. So some of my favorite sources, HighTech Trash by Elizabeth Grossman is just a great, great book. She's a journalist who did a very good job of getting to all the facts and figures of the issue, but she also did a really excellent job of understanding the scope. She did everything from understanding the life cycle and how much materials goes into a chip to the implications for prison labor in the U.S. She just went everywhere. She did a really good job. So I would recommend all these sources. And one more source. In about a week, check on Scribd under Green Thumb Geek. I'm going to post this presentation, and I'm going to try and include the notes. In the notes, I'm going to try and put my resources, all my sources. So if you want to do more research into this, you're welcome to do that. Please feel free to get in touch with me anytime you want. I'll be around all weekend, and please come visit Hive 76. And I'm really eager to hear what you have to say and hear what you're interested in. So let's open the mics.
John, good presentation today. I apologize for falling asleep halfway through it. I needed a hammock, but I am interested. That's why I'm here. Stephanie, first of all, thank you for providing the doctors at Penn with all the information they needed to cure my cancer. Okay? So maybe if I survive cancer once, I'll survive it again. But it seems to me that there must be a parallel between all of the chemicals that are needed to make all this stuff and the chemicals that are needed to get the valuable stuff back out of it. So there may be a parallel between consumer and business waste and the manufacturing process and their waste products.
Sure.
You know what I'm saying? And as they phase out material, some of that may contribute to a process to, like I was thinking, the disassembly, I'm thinking like a sawmill, we're not going to put it back together again, we're just trying to get at the components, so some sort of collaborative effort maybe in zones around the country, as you said, 25 million of dead weight to do it on your own. So, I mean, these must be thoughts that you've had already. And plus,
Yeah,
I'm from South Philly too. I just got to say, okay, so
Nice.
I'm cool with the 100-year-old house.
Yeah, the point that you're making is a very good one, and it's one that gets considered by the industry a lot. So I think the heart of your question is, can some of the outputs of these destructive processes be inputs into some of the solution? And again, I'm not a chemist and I'm not an industrial engineer, but yes, there is opportunity for that for sure. One of the problems is matching up the producer with the consumer and getting the quantities right. So okay, so those relationships are kind of hard to meld. But it's something to look into for sure. We're a little low on time, but yeah, go for it.
Oh, okay. Really quickly, back in my home state of North Dakota, I ran an organization which took refurbished computers from our school and gave them to dispossessed populations in the community. We were able to get computers for free, space for free. It was an idyllic, setup. However, inevitably there's trash. And so what we found was the only thing that we would ever have to pay for was trashing spare things.
Sure.
Post-mortem, in a small community, what could I have done possibly to do that without
Without incurring the cost?
without incurring any cost?
Do you know a good grant writer?
Yeah. In the end, it just ended up being driving from dumpster to dumpster and throwing things in random dumpsters, which is
It's
horribly unethical.
not the best solution. Some people might argue that it's actually not the worst solution, but I don't have an easy answer to that because I am an advocate of paying to do it the right way, but I completely sympathize with the idea that when you're working in a low resource situation, there's just not a good solution to that. I guess I would look for good funding. If maybe some of the organizations that are donating computers might be interested in handing you $20 to recycle it correctly. There are a couple of retailers who will take your computers for free, like, I don't know, Staples or Best Buy or something.
Thank you.
I'd just like to point out a couple of unintended consequences of the whole RoHS
Okay.
legislation.
Yeah, I'm really interested in this.
The foremost would be really rather stupid that you end up with two products that do the exact same thing but have a different part number.
Right.
And a whole bunch of people who are now convinced they need to order this new one even though it's not different at all, except the solder it was built with. The other thing is with the lead-free solder, there are potential reliability issues.
Liability? You mean with?
Reliability rather than liability.
Okay.
Tin whiskers are the foremost. They're metal-conformed crystals that grow over time and eventually cause shorts.
Right.
That with the combination of the chip packages that are used nowadays, ball grid array, BGA, is the one where you can't see any of the pins except they're underneath.
Okay.
It floats on a grid of little solder balls, essentially.
Okay.
You have a whole lot of component leads that are now in close proximity, and if you have crystals grow between them, all of a sudden you have a short or two I/O pins that are tied together.
And
things
possibility
go-
for fire, right?
Well, probably not, but failure in any event.
Okay.
And that could adversely affect especially military electronics or anything critical.
Yeah, I am aware that there's a whole movement that's frantically anti-lead-free solder.
And at least right now, all the e-scrap that goes through the U.S. mostly is broken down to the circuit board level, but not beyond it.
Okay.
And then it's all shipped overseas.
Okay. I'd really like to talk to you about this. And unfortunately, the gentleman who's running the show is telling me to wrap up.
One quick final comment about what a large organization can do, what you were alluding to, if they want to better manage their obsolescence and their electronic components, is they could include it in their procurement contract.
Yeah, absolutely.
That the and I think University of Massachusetts and maybe the Commonwealth of Massachusetts have done things like that to require the manufacturer to pay for the pickup,
Yeah.
take the responsibility for it. So that's
Yeah.
one option.
Absolutely. All right. Thank you so much.